Today we are going to work with UDGs, user-defined graphics. This isn't a resource that is widely used in modern programming, but it's a very simple way to create and manage graphics in a straightforward manner. What's more, everything we learn here will serve as the foundation for the next chapter. So, let's open ZX Basic Studio and create a new project using File, New Project. We create a folder inside CH Tools /projects with the name Graphics Test and select that folder. We define main.bus in the main file field and leave the rest with their default values. That's it. Now we create the main file using file new file, category code, and type ch basic file. We give it the name main.bus and click on create file. We now have our main basic file, but for the moment we'll leave it aside and create a file for the UDGs. We can use file new file or the new file icon on the toolbar. We select the graphics category and the UDG file type. We adjust the file name to test.udg and click on create file. The test UDG file will open automatically and show us the UDG editor. UDG, as their name indicates, are user-defined graphics. As we have 21 characters available in 48 mode and 19 in 128 mode, because 128K machines use the last two graphics to store the spectrum and play tokens. So in 128Ks we have two fewer UDGs. On the left we have the patterns panel. You'll see that the number is shown in cyan color and the UDG letter in white. The selected UDG is shown in red, and this is the one displayed on the central area. By clicking on any pattern, you can edit the design of the UDG using the left mouse button to light up the pixels or the right button to turn them off. At the top, we have a series of icons that allows us to perform various actions: clear the UDG, cut, copy and paste, horizontal and vertical mirrors, rotations, circular or non-circular shapes, invert pixels, generate a mask, we'll look at it later, and data export option. As an example, I'm going to create a heart graphic so that in my game, instead of showing the number of lives as a number, I can show 1 heart per life. I'm going to clear the entire UDG with the clear active partner icon and draw a heart. And while I'm at it, I'm going to duplicate this heart in the UDGB by copying and pasting. Now I have two identical hearts. I'm going to copy another into UDG-C, and now I'm going to fill A completely and half fill B. That show a full, half full, or empty heart. If you look closely at the bottom, I have a zoom control that enlarges or reduces the pattern, and two controls, width and height, which allow me to control how many patterns I want to see at the same time. This is very useful when I want to slightly larger graphic. For example, if I set to width 3 and height 1 by selecting UDG A, I can see the three hairs at the same time. On the right, I have an area called preview that helps me to see how everything is turning out. First, indicates the graphic that is displayed, in this case 0. But if I change it, you'll see how it changed below. Frames indicate the number of patterns I want to see in the animation. If I set it to 3, you'll be able to see 3 hairs one after another. Width and height allow us to define how many graphics we want to see at the same time. If we reduce the number of frames to 1, it's easier to see. A speed defines the speed of the animation, although this is only to preview how it looks. And zoom allows me to control the size of the preview. Now let's see how to display this on the screen. The first thing we'll do is to save the work with the Save File icon, and then click on the Build Export icon. This window allows us to define how we want to export the UDGs, and although this may seem complicated, it is already set to the good default option, which is the dim format. This format generates an array with the data of the 21 UDGs, which allows us to use them in a very natural and powerful way. The Enable Void option makes it so that every time we compile and run our program, the graphics are exported and updated. So once these options are configured, any change to the UDGs will be automatically reflected in our program. The file path field defines the file that will be used to export the data. It must be a new and temp file, as it is destroyed each time, and it's normally the same name as the UDG file, but with the .ZX Basic extension at the end. Although I prefer to change that extension to .bas. Label name indicates the name that will be used for the byte array. We'll leave it as test for now. Array base is included for compatibility reasons, but it is usually left to 0. Here we have an example of usage. As you can see, first variable called n is defined, then an array called test, which has 21 elements of 8 bytes each. These numbers are simply the data of our UDGs in hexadecimal format. If we scroll down, you'll see an example of use. So we save the changes with save options. When we save the options, we'll see that a new basic file called test UDG bus has been created. If we open it, we'll find the definition of the UDGs and a warning indicating that the content of this file are erased on each compilation, so we should touch it. We go back to main bash file and type the following listing: sharp include quote test UDG bash quotes. This line inserts the file test UDG bash onto main bash. In other words, it's as if we had typed test UDG bash content at this point. Pay attention to this includes. They're going to save us a lot of time and effort. We continue typing poke u integer 23675, at test 0, 0. At test returns the memory address of the variable test, and what we are doing is adjusting the spectrum UDG variable so that it points to our own graphic. In earlier versions of the compiler, it was possible to type at test without the 00 due to a bug, but in more recent versions of the compiler, we have to indicate the first element of the array. In this case, at test 0, 0. And we finish with the line print, lives /a/b/c. To print UDG, we can use its ASCII code, which is 144 plus the UDG number, or use a backslash before the UDG letter, which is easier for the time begging. Let's run it with F5 and we can see the result. If we now go back to the UDG editor and modify the graphics and press F5, we'll see that without doing anything else, the UDGs have been updated automatically, which saves us a huge amount of work. I hope you like it, and although, as I said before, UDGs aren't something that is used in modern development. In all basic games, they were one of the most widely used ways of managing graphics. See you!